Hi everyone, I'm Professor Stugard and I'm back in this video on sampling and bias. This is something that's super important to statistics. When we do statistics, we can't usually collect data from everyone. So instead, what we do is we rely on a sample, which as you guys know is a small group that represents a larger population. But here's the thing. How we choose that sample really matters. If we don't do it well, our data might be misleading, and even if we analyze it perfectly, it can still be misleading. So this is a really important discussion that we're going to have today. So let's dive in and see what this is all about. So remember, there's just a lot of critical vocabulary in statistics. So it's important to kind of check in with those key terms that we learned in the last few sections. So let's start with a quick review of key terms, and please make sure that you guys have these in your guided notes. That's going to be really important. So the first term is population, and that's the entire group that we want information about, okay? Drilling down a little bit, we have our sample. That's the smaller group that we actually collect the data from. And then drilling down a little bit more is the individual, which is just one single member of that sample. We have parameter, which is a number that describes the population. And of course, along those same lines, we have a statistic, which is a number that describes our sample. Okay, and so in the last video, we kind of talked about the way to remember that. When we're talking about a population, the number that we use is the parameter. We have the P for population, the P for parameter. And when we're thinking about a sample, a smaller group, the number we use to represent that is the statistic. So we have the S for sample, S for statistic. Okay? Okay, so why does sampling matter, right? Let's say we want to know how all Americans feel about student loan forgiveness, right? That's our question. We have this poll question for Americans. How do you feel about student loan forgiveness? Well, we clearly cannot ask everyone, right? We can't go around and ask every single American in the country. We just can't do that. It'll be crazy expensive, and it's just not reasonable. It's not a reasonable thing for us to be able to expect to do. So what do? How do we solve that problem, right? Instead, we decide, well, let's just take a sample. How about if we only ask students in a college lounge? What do you think might happen, right? Let's think about that for a second. Well, if we only ask students in a college lounge, we will probably get skewed results, right? Because there's some bias there, right? There's going to be bias. If we're only asking college students about student loan forgiveness, they're going to have a very biased answer, right? They have a lot on the line there. They're in college. If it would be really helpful and really advantageous for them to get their student loans forgiven. So we're probably going to have skewed results, right? There are probably going to be a disproportionate amount of students that would say, hey, student loan forgiveness is a great thing, right? Because I want my student loans forgiven. That would really help me get a leg up in life. But is that really representative of our population, the American population at large, right? And so that bias, that's a major threat to the validity of any study. And that's why it's so important to think really carefully about how we can combat that bias and make sure that when we take a sample, we do everything in our power to ensure that there is no bias that's going to be introduced. So big question here, right? What is bias? And I'm going to give you a definition. In statistics, bias happens when a sample doesn't accurately represent the population, okay? And so the result means that if we introduce bias into our sample, our conclusions may be completely off, right? And sometimes we do everything in our power to try and combat this, and we still might wind up with skewed results. There might be something we missed, or we didn't think it all the way through. But as statisticians, we always want to do our best to make sure that we're not introducing that bias, okay? So let's look at different types of bias that you need to watch out for when collecting data and talk about what we can do about them. Okay, so the first type of bias we're going to talk about is called sampling bias. And sampling bias is when the method of selecting the sample favors one part of the population. Okay, so as an example, if we are surveying only college students about student loan forgiveness, that's not good, right? We're missing a huge portion of the population there, and our sample is just not going to be representative of that population. And so a common source of sampling bias is a convenience sample. And that basically means that we're choosing people because they're easy to access, right? It's convenient, right? It's really convenient for us. They're right there. And so we're just going to take this sample. That may introduce some bias, okay? That usually leads to undercoverage, something we call undercoverage, which means there are entire groups left out of being represented in our sample, okay? So that's our first type of bias, is sampling bias. Let's look at our second type. So the second type of bias we're going to look at is called non-response bias. And so basic definition for that, we pick a good sample, but many of them just don't respond, right? It's exactly what it sounds like, non-response. Sometimes you just don't have control over that. People just don't respond. An example of this is conducting literally any kind of phone survey. The problem is if only certain types of people answer, you're still missing perspectives, right? We only are getting the perspective of the people that actually pick up the phone and want to give their opinion, and that might lead to some pretty skewed results. This happens even if the initial sample was fine, right? We have this list of people we're going to call. Maybe that list is very representative of our population, but then when only so many of them pick up the phone, well, then we're going to introduce some non-response bias there. We also see this in online reviews. People who feel very strongly, whether it's positive or negative about a product, are much more likely to respond, and this can really skew perception. All right, so that's non-response bias. Let's look at our next type of bias. So we just talked about non-response bias. Now let's talk about response bias. And this is when people do respond, but their answers aren't accurate. Why might this happen? It could happen for a few reasons. The question is confusing or poorly worded. I mean, think about it when you have double negatives and weird language or ambiguous language, it could lead to a confusing question or a poorly worded question, and people just don't know how to respond, or they respond in a way that might not actually answer the question. And that's not really on them, that's on the way the question was designed. And so you always want to be really clear and explicit. This can also happen when people want to give a socially acceptable answer, right? Maybe they're embarrassed or they feel unsure about something. Or they don't want to kind of rock the boat with their answer by actually being honest about it. And we've all experienced that, right? They might just overestimate their abilities. This happens all the time. You ask somebody about a skill that they might have or that they don't have, and they might say, yeah, I'm really, really great at that, or I do that all the time, when in reality they don't. So here's an example. A survey asks, have you ever done something illegal, right? You might not get honest responses there, right? People might feel embarrassed or unsure, or they want to give a socially acceptable response. And even if it's anonymous, you might not get honest responses there. So, these are all different ways that response bias can kind of come out in a study. Okay, so let's look at our next type of bias, recording or processing errors, right? Guys, mistakes happen. A human can misread, mistype, or enter information wrong. And even small errors at this stage can mess up everything we do later when organizing and analyzing. There is, some ways that technology can combat this, right? Humans are humans. There's a reason we're not machines, right? We are imperfect, and that's okay. It's a good thing. But this can lead to recording or processing errors, which can introduce bias into our sample. So now that we've talked about all the different types of bias, let's talk about how we can avoid it, right? How can we do that? Well, honestly, there's no perfect sample, okay? But there are sampling methods that help us to reduce bias and increase accuracy. So let's go through the main types of sampling methods that can help us do just that. So our first sampling method is called the simple random sample, SRS for short. And this means that every member of the population has an equal chance of being chosen, okay? So for example, pulling names out of a hat or using a random number generator, right? That says, okay, pick person 2. So we take the second person, and then it says pick person 5. And then it says pick person 6, right? We're randomly generating numbers. We're pulling things out of a hat. Everybody has an equal chance of being chosen. This method is ideal, but it's just not always practical, especially with really large populations. So it's a great method, but like I said, it's just not always practical if we have a huge population from which are pulling our sample. So let's talk about our next type of sampling method. Okay, so the next type of sampling method that we have is called the stratified sample. And that's when we divide the population into non-overlapping groups called strata, which is where this stratified comes from, based on a shared characteristic, then randomly select from each group. So for example, we might take a population and split it by age group or maybe gender, and then randomly select people from within each of those groups. So if I look at this image here, right, maybe I split my population into age group 0 to 20 here, and then age group 20 to 30, and then maybe I have age group 30 to 31 to 40, and then I have 41 to 50, and so on and so forth. And then from within the 0 to 20 group, I randomly select a few members. From within the 21 to 30 group, I randomly select a few members. From the 31 to 40 group, I randomly select members of that from that group. And so this helps to ensure each subgroup is properly represented. The important thing here to remember is that you want non-overlapping groups, okay? Meaning whatever characteristic I choose to split them into groups by, I can't have any sort of overlap there. So like if I do age group, right, there's not going to be somebody who's both 21 and 40 at the same time. That's non-overlapping. So that's really important to make sure that you do not introduce bias into that. So the next type of sampling we have is called cluster sampling. And that's when we divide the population into clusters, often based on location or convenience, and randomly select entire clusters to include in the sample. And so, for example, let's say we have a school and it selects 3 entire classrooms to survey instead of selecting random students across the whole school. Okay, so that would be us taking each of our classrooms. Okay, let's say there's maybe 8 classrooms across the school, and we say, okay, we're going to randomly select classroom 1, classroom 4, and classroom 7, and we're going to take those every single individual in those classrooms. So it is a little bit different than stratified sampling. So there's some key differences here, and these often get confused because in both methods we're creating smaller groups, and so the key difference to kind of help you remember is that in stratified sampling, we sample from within every single group, but in cluster sampling, we choose a few whole groups. So like how we divided our population into smaller groups with stratified sampling based on age, we're taking a sample from every age group, but we're just taking a few select members from within that group. Whereas with cluster sampling, we only take a few groups, but we take everybody, every individual in those groups. And so we're going to break that down a little bit more on the next slide. So here's kind of a visual to help you understand. On the left, we have stratified sampling, and here we took our entire population of fruits, which in this example happens to be apples and oranges, and we split them into strata, or groups based on type of fruit. So one group was apples, because that's one type of fruit, and one group was oranges. And then we randomly select from within each sample. So we took these 2 apples, and randomly we took these 3 oranges. So it's important to note we're still using the entire population of fruit that we started with. Whereas on the right, we have cluster sampling. And here our clusters are different families. We have randomly chosen. So if this is our whole population, right, all these families are our population, we decided to cluster these people by families. But then we have randomly chosen entire clusters to take as our sample. And so here it's important to note that we aren't using the entire population of families that we started with, right? This family doesn't get included at all. No members of this family, no members of this family, no members of this family. But we took entire clusters, okay? We're just randomly sampling clusters from within that population, and that's sort of the key difference. So if you get kind of confused about those, come back to this visual and hopefully it'll kind of help you think it through. Okay, the last sampling method we're going to talk about is called systematic sampling. And this is when we choose every kth individual from a list. So for example, maybe we choose every 10th person entering a store to take a survey, right? Kind of like you see in this picture here, we chose every 3rd person, right? So we sample and then 1, 2, 3. The next person, 1, 2, 3 is the next individual, okay, and so on and so forth. This is often used in exit polls or production quality checks because it has the benefit of being quick and orderly, which is really nice. So we just say, hey, we're going to sample every 5th person, and that's what we do. Okay, now let's talk about sampling variability. Even with good techniques, there will always be variability in samples. It's just the nature of the world, honestly. That means that different samples can produce slightly different results, but don't worry, that's totally normal. So for example, let's say you survey one stats class and find the average height to be 5 feet 6 inches. Well, a biology class might average 5 feet 8 inches. That doesn't mean that stats students are shorter, it's just normal sampling variability, right? There just happen to be some taller people in the biology class as opposed to the stats class. One general rule is larger samples tend to equal much more accurate results, as long as they're collected without bias. So honestly, the larger your sample size, the better your results are going to be, the more they're going to skew towards the actual population parameter. So as long as you collect them without bias and you think through all those different types of sampling methods and types of bias we talked about earlier. So to wrap things up, here are a few final questions to ask yourself. What does bias mean in statistics and in the real world? What are the common sources of bias in data collection? And can you describe the differences between a simple random sample, stratified sampling, cluster sampling, and systematic sampling? And most importantly, how was this data collected? This is the first question you should ask yourself anytime you see a statistic being used to make a claim. Our discussion this week will kind of get at the heart of this question and ask you to consider it in regard to the data you see every day online, on social media, in the news, and among friends. You should always ask this question. So to wrap things up, bias is everywhere. But with the right tools and critical thinking, we can minimize its impact and collect more meaningful data. And next up, we'll start looking at how to summarize the data numerically that we collect, so stay tuned. Thanks for watching, and as always, take care and reach out if you need anything.